So we're going to do chapter 8, and we're doing some examples on chapter 8.2. So one thing we've got to understand to do is, how do we find alpha? So if my confidence level is 96, and remember, one thing we've talked about is that we can't use percentages in an equation. We have to use the decimal. So alpha is equal to 1 minus my confidence level. So that's 1 minus 0.96. I got to turn the 96% into a decimal. Therefore, alpha in this case is 0.04. 1 minus 0.96. So alpha is 0.04. Now here we have a confidence interval for a population mean. It has a margin of error of 4. That means E equals 4. So we have to remember that what we're doing then is X bar plus or minus E. So we have X bar minus E all the way to X bar plus E. So what is the length of the confidence interval? Well, we have from a negative 4, so we're minusing 4, and then we're adding 4. So my confidence length, the length of the confidence interval is 8. 4 plus 4. The length of the confidence interval is 8. Because I'm subtracting 4, I'm adding 4. So it's 8 overall, from negative 4 to plus 4. So here I have the mean score on aptitude test was 71. So X bar equals 71. I have standard deviation is 13. I know the standard deviation, they're giving it to me. I want a 95.44% confidence interval for mu. So what do? We have to remember, okay, my equation is this: X bar plus or minus Z of alpha divided by 2. Because remember, we're going down and we're going up. We're subtracting and we're adding. So we have to go down half of that alpha and then up the other half. Okay, so it's Z times alpha over 2, or Z to the alpha over 2. And then standard deviation over the square root of n. Okay. So the sample was 3 students. So n equals 3. It's pretty simple. Okay. N equals 3. So first of all, what's alpha? Alpha equals 1 minus 0.9544. Okay. So if I have 1 minus 0.9544, I get 0.0456. 0.0456. That's alpha. But when I'm looking at my chart, I need to find alpha over 2. So alpha over 2 is 0.0456 divided by 2. So I'm going to divide this by 2, and that gives me 0.0228. 0.0228. So I have to look for my Z that gives me 0.0228. So I'm going to come over here to my chart, and I'm looking for 0.0228. And lo and behold, 0.0228 is right there. And that's negative 2.0. And then this is 0. So it is negative 2. So the Z of alpha over 2, the Z of alpha over 2 is going to be 2.0. Okay. So now, in order to find my confidence interval, I'm going to use my equation. They give me the X bar. It is 71 plus or minus I have my z of alpha over 2, which is 2.0. Now we found it as -2. Remember, when I'm adding a negative, that's subtract. When I subtract a negative, that's add. So it's going to balance itself out. So I can use just 2.0. Standard deviation is 13. And we said n was 3. So it's a square root of 3. So I have 71 plus or minus so I have 20 times 13 divided by the square root of 3. So 20 times 13 divided by the square root of 3 gives me, that's 2, not 20. Look at me, I forgot my decimal. Made that mistake. We got to be careful what we're doing. I thought that looked too big. Let's try it again. Clear it out. It's 2, not 20. 2 times 13 divided by the square root of 3, which gives me 15.01. So 15.01. Did I round that correctly? 15.01, yep. So I'm going to have 71 minus 15.01 gives me 55.99. And then I'm going to add 71 plus 15.01 gives me 86.01. And if I round those, this is 56 and 86, which is this right here, A, 56 to 86. Okay. So let's look at problem number 4. Now I want to know what the margin of error is. So I'm looking for E. Find the margin of error. I'm just looking for E, which is Z of alpha over 2 times the standard deviation over the square root of n. Okay. So I have my mean of my sample, which is 1.69. I have the n, which is 49. This is my n. So n equals 49. I have standard deviation of 0.46. Standard deviation is 0.46. And I want a 95% confidence level. So this means that alpha is 1 minus 0.95 or 0.05. And remember, my equation, E equals, this is my just the margin of error. It's this right here. So it's Z of alpha over 2 times the standard deviation over square root of n. So then what's alpha over 2? Well, if alpha is 0.05, alpha over 2 is 0.05 divided by 2 or 0.025. So that's the alpha over 2. And I have my standard deviation. I have my n. So now I just need this Z of alpha over 2. So I'm going to come back to my chart and I'm going to look for 0.025. We've used this before. And we see right here, I got 0.025. That is negative 1.96. So negative 1.96 is my Z of alpha over 2. So I'm coming over here. So my Z of alpha over 2, which is my z of 0.025, is 1.96. So then my equation for my margin of error is 1.96 times the standard deviation, which is 0.46, over the square root of n, and n was 49, so it's the square root of 49. And I'm going to go to my calculator. So I have 0.46 divided by square root of 49, which we know is 7. Oops, I typed in 46, making mistakes. 0.46 divided by 49 square root, which we know is 7, which gives me that fun thing. Multiply that by 1.96, and that gives me 0.128, which if I round is going to give me 0.13. So my answer for this one is 0.13 ounces. That's my margin of error, plus 0.13 minus 0.13. So now we're going to look at this, okay? Weights of a women in one age group are normally distributed with a standard deviation of 10 pounds. So my standard deviation is 10. A researcher wishes to estimate the mean weight of all women in this age group. How large a sample must be drawn for a 90% confidence interval? So I want 90% confidence level. And I want the sample mean to not differ from the population by more than 3.4. Meaning I want E to be 3.4 pounds. I want my margin of error to be no larger than 3.4. So I'm looking for N. What is N? Okay, so 90 confidence level. Remember, I need alpha, which is 1 minus 0.90, which is 0.1. But I need alpha over 2 because I look for z of alpha over 2. So alpha over 2 is 0.05. So I need z of 0.05. So I come over to my chart. I look for 0.05. 0.05. And I have 0.0495, 0.0505. So I have negative 1.6, but I need to go in the middle of these two because they're the same distance away from 0.05. So I come up here and it's between these two. So it is 1.6. And it's between the 4 and the 5. So it is 1.645. So that is the Z that I need to use, 1.645. So my Z of 0.05 is 1.645. So now I'm going to go and I'm going to look at my equation. E equals Z of alpha over 2 times my standard deviation over the square root of n. I want an E of 3.4. That's right here. So 3.4 equals my Z of 0.05 is 1.645. My standard deviation is 10. And I'm looking for N. Okay. So I multiply this by 10. I get 3.4 equals 16.45 over square root of n. Remember, I can flip these two. If I multiply this over here, I have to multiply it over here. So this gives me 3.4 square root of n equals 16.45. And now I can divide by 3.4. The square root of n equals 16.45 divided by 3.4 gives me that monstrosity, 4.838. But I know I have to square this. And I'm going to square this in order to get n. So n equals, and I'm going to come here and I'm going to square this answer. And that gives me 23.4. But I need at least 23.4 to give me that confidence interval. I can't have 0.4 of a person. If I have less than that, then I won't get my confidence interval. I must round up. So I need to have 24 people in my sample. And there we go, 24. That is where that comes from. I have to round it up from the 23.4 to 24 because I need at least 23.4 people to give me my 90% confidence level. So then that means I must go up to 24. And that's it for this one.